In the morning session, we were discussing about brief about programmable logic devices, and then we continued it to uh, CPLDs. Okay? So let us continue with that. And I think I was here. So this is the block diagram of CPLD. Okay. Actually, it is a block diagram of XC9500. So commonly, all CPLDs will have functional blocks, that is a logic block, then interconnect matrix, that is the interconnections, uh, and then IO blocks. These are the blocks which are present in a CPLD. So that we have seen earlier, and now here, whatever is in interconnect matrix, that is a crossbar switch. Okay, so because of this crossbar switch, we can do the connection between the inputs and outputs. Okay, so wherever we want to connect it, using these crossbar switches, we can do the connection. So this is the structure of crossbar switches, and if we are considering only one switch, then it will look like this. Okay, so it will be look like this. So here there are some flip-flops. We can program in such a way that there will be connection. Okay, and here this structure is diamond-like structure. Okay, so that is why it is also called as a diamond switch. So that is present in a interconnect switches. So depending on how we are connecting it, there will be connections from the functional block to another functional block, or it could be a connection from functional block to IO blocks. Okay, so it may route through interconnect matrix. Then if we are considering about what is there in a functional block, okay, so this is the functional block of CPLD, which has a programmable AND array, and then with this input to this AND array is from the fast connect switch matrix. Okay, so it is a 54 pins fast connect switch matrix for XC9500, and then output of this AND array that will produce certain product terms. Okay, so these product terms that will be allocated to the macro cells, which will produce certain outputs. So these outputs from macro cells that can be connected to fast connect switch matrix, or it could be connected to the IO blocks. Okay, so these will be the connections from the macro cells of the functional block of CPLD to the other connections. Okay. Now here, to operate these macro cells, as we know that in a macro cell there is a D flip-flop present. Now if we want to use that flip-flop, then we need certain clock signal as well as set and reset signal. So global set and reset signal and global clock signal that is connected to the macro cell. Now in a CPLDs, if we are considering the case of XC9500, then there are three global clocks that are present and one set and reset signal that is present. So that will be connected to these macro cells. Okay. So that is about the functional block of this CPLD. Okay. So total overall these functional block that with a macro cell will look like this. Okay, so here there are programmable interconnect signals. That means there will be a literal inputs. That is, suppose A, B, C. These will be the inputs that are shown over here. So it could be either in a positive polarity, or it could be in a complement form that will be present here. So that we can program in such a way that depending on whatever product requirement, so we can connect that connections, or we can keep that connections, and others that we can remove. Okay. Then there is a uh, 16 expander product terms, so that here we can expand that product term, so that product terms that could be there. And then the main part, that is a PLA like AND array, that will be present. Okay, so this uh, PLA like AND array, that will produce a product term. Okay, and out of the whatever product terms that are produced, so some of the product terms that will be selected. Okay, so they, here it is a block, that is a product term selector block, that will is a present in a functional block. Okay, now output of this product terms, that is given to OR array, and then output of this OR array, that is connected to the macro cells. Okay, so now here, depending on the application, whether we are just designing a combinational circuit or sequential circuit, it will be connected to the flip flop. This output of OR array, that will be connected to the flip flop, or it could be to the it will be bypassed, and it will be directly given to the multiplexer. Okay, so 2 as to 1 multiplexer, that will be there, and then output of that will be given either to IO block or to the programmable interconnect array, that is a programmable interconnect matrix. To that it will be given. Now, as I earlier said, there are certain global set and reset signal, that is a clear signal. Then there are global clock signals that are present in the functional block, that we require for the functioning of this circuitry. Okay, so these are the connections which are present in the CPLD function block. Okay, so this is the connection for XE9500. Now, as we discussed earlier, in a macro set, okay, so I am repeating this again. In a macro set, we have and or configurations. Okay, so 5 to 20 AND gates that are present, and OR gates with 5 to 20 inputs. Okay, so OR gates that are lesser in a number. Okay, but the input which is applied to these and OR arrays or OR gates, that is a 5 to 20, depending on how many AND gates are there. So that on that, this will be decided how many number of OR gates that are connected. Okay, at the same time, there is a XOR gate which provides inverted or non-inverted output of OR gate, and then there is a D flip flop that is present, and then multiplexer and buffer. Okay, so these are the components which are present in the macro cell of this CPLD. Now, what is the purpose of these macro cells? As we have seen earlier, that whenever we are using a PAL structure or PLA structure, that time if we are going for more number of inputs, that time what happens? Fan-in of AND gate that increases, and which slows the performance of that circuitry. And so to reduce that or to increase the efficiency of that circuitry, we are using macro cells. So because of these macro cells, we can increase the number of inputs. Okay, no, though it is not a direct input signals, but we can internally, we are increasing the number of inputs by programming of these macro cells. Okay, so these are the components that are used in a macro cell. So remember that there are certain and or configurations, then XOR gate, D flip flop, multiplexer, and buffer that is present in a this macro cells. Then what is advantage of CPLD? Okay, so whatever we have seen now, so that was the architecture of CPLD, and now let us come towards the what is advantage of CPLD. Now the one thing is that it is easy to design. Okay, so ease of design is one of the advantage of this CPLD with use of HDL. Now it may be Verilog or VHDL, and then CPLD development tools. So whatever is the board available, connection connectors. So with that, we can easily design any logic circuitry on the CPLD using this CPLD. So that is the ease of design is the one advantage. Then reduced board area, that is another advantage of CPL. So, as in a CPLDs, we are using VLSI technology. Okay, so that means we are minimizing the component sizes in a single chip, and all these components that are which are fabricated in this chip that are very small in size, and that is why overall board area that reduces in a CPLD. Okay? So that is a again advantage of this CPLD. Now, due to less maintenance, we require less cost. Okay, so here for CPLD, very less maintenance is required for that board. So that is a again advantage, and lower development cost. That is also one of the advantage of CPLD. So because of that, we can get more revenue from the product. As the development cycles are very short, and uh, it can get into market quicker, so it generates revenue sooner. So whatever application that you are implementing, so that can be done in a very small period of time. Okay, that means whatever development cycle that is required for CPLD design, that is of a very short duration, and because of that, you can launch your product into market uh, quicker. Okay, and because of that, again, what revenue generation that will be sooner, and so that is the one more advantage of CPLD. And most important advantage is that it is a uh, very reliable application, or a very reliable mechanism. Okay. So you can easily rely on whatever you are designed, that is going to be um, correct. Okay, because as in a this Altera Max 7000, okay, we have JTAG um, technology for the, also we have boundary scan technology. So that means on chip testing that we can be done using the whenever we are using CPLD, and that is why you will be sure before implement or before fabrication, you will be sure that whatever we have designed, that is correct one. Okay? So that is the one more advantage of using CPLD. The most important thing is that you can implement a very larger circuitry on a very small size. Okay, if you are doing it with a simple PLDs, then you may require large number of PLDs, and then the size of that circuit that will become large. But with a complex PLDs, you are going to reduce a board area, that means size of the circuit. Okay? So that is the advantage of CPLD. Okay. Now let us move further, and now we are going to discuss about FPGAs. Okay. So again, FPGA, it is a programmable logic device. But whenever we are considering programmable logic devices, the first that comes into our mind, that is the SPLDs and CPLDs. Okay. So that means simple programmable logic devices and complex programmable logic devices. But when we are going for the FPGAs, okay, then with respect to FPGAs, these SPLDs and CPLDs that are relatively small. Okay? And when we are going for implementing simple logic devices, then at that time these are useful, because uh, these circuits that have nearly about 20,000 gates. So uh, it is useful when we are designing a simple and small logic devices. But FPGAs, that is a filled programmable gate arrays that can handle larger circuits. And again, one more advantage of these circuit is that they are not having and or planes. Okay. Also, they provide logic blocks and interconnection wires and switches. So here, as there is no any and or plane, and the whatever programming technique that we are using in a FPGA, that is a SRAM based technology. So we can program FPGA any number of time. Okay. Now the life of programming that we can use in SPLDs and CPLDs, that is limited, but here we can program FPGAs any number of times. So that is the advantage for using FPGAs. Then logic blocks that provide functionality of the circuit, interconnection switches which are used in a FPGAs that allow logic blocks that to be connected to each other. So whatever logic blocks that are present in that FPGA, and also it can be used to connect to IO pins. So remember that now in a FPGA, what we have logic blocks, IO blocks, and interconnection wires and switches. In a CPLD, what we were having, what are the different types of blocks? We were having functional blocks, IO blocks, and interconnection switches. Okay, so just now that means actually in both of these CPLDs and FPGAs, we have similar types of blocks. Okay, that we have logic blocks, then we have IO blocks and interconnection wires and switches. So these are similar, but the only difference is that in a CPLDs, in the logic blocks, we have and or planes. Okay, and in a FPGA, we have lookup tables. Okay, so that is the difference in this FPGA and CPLDs. Okay, so this FPGA families that are available in the market, that are depending on the how we are using programming techniques. Okay, so that means if it is a SRAM based, then we have Altera Flex family, Atmel 86,000, 8040K families. So all these families that are present. And for the anti-fuse based FPGA families, Actel XX and SMAX MX families, and QuickLogic PSIC family. These are the families that are available. But our interest is in a Altera Flex family. So we are going to see for these families, that is the Altera Flex 10K family. Okay. So overall, uh, this FPGA that was introduced in 1985, and the companies which manufacture FPGA, that are Actel, Altera, then Algotronics, QuickLogic, AMD, then Crosspoint Solutions, Xilinx, etc. Okay, so when we are considering about programmable logic arrays, it has hundreds of gate equivalent. Okay, but whenever we are going for FPGAs, it has 100,000 gates. That means if we group 1,000 gates in a one group, or we make a group of 1,000 gates, then such 1,000 gates groups are available in a FPGA. Am I audible? Hello? Hello? Am I audible?
Yes, ma'am.
Okay.
Yes, ma'am.
I thought network issue was there. So, okay, is it my screen is visible to all? Okay, in case any
Yes,
problem,
ma'am.
please tell me. Okay, because I think there is a very bad weather. So maybe network issue may be there. So please tell me. Okay. Uh, so uh, as we discussed earlier, FPGA in a FPGA we have logic blocks. So it here you can see this is the logic block. Then interconnect uh, wires and switches. Okay, so these are the interconnects to connect input and output to logic blocks and IO blocks. Okay, so these are the IO blocks that are present. Now here you can see the architectural difference in a FPGA. Okay, in a FPGA we have logic block. Okay, and then these interconnects that are placed like rows and columns. Okay, so you can see these interconnects around each of the लॉजिक ब्लॉक. ओके, प्रत्येक लॉजिक ब्लॉकच्या भोवती तुम्हाला इंटरकनेक्ट दिसतील की त्यामुळे तुम्हाला इझिली तुमचे जे काही कनेक्शन्स आहेत ते करता येतील. दॅट फॅसिलिटी यू वेर नॉट देअर इन केस ऑफ सीपीएलडी. सीपीएलडी मध्ये कसं होतं की जो इंटरकनेक्ट स्विच मॅट्रिक्स तो एकच अवेलेबल होता, पण इथे काय आहे, इथे तुम्हाला रो वाईज आणि कॉलम वाईज interconnect दिसतील. So you can easily connect it. And then IO blocks that are present on the periphery of your chip or device. So, त्यामुळे इझिली तुम्हाला पिन्स अवेलेबल होतील आउटसाइड. तुम्ही जर एफपीजीए बघितलात तर तो स्क्वेअर शेप मध्ये तुम्हाला मिळेल आणि त्याचे सगळे पिन्स जे आहेत तर ते कुठे दिसतील तुम्हाला, त्याच्या प्रत्येक म्हणजे प्रत्येक साईडला पिन दिसेल. सो ऑन द पेरिफेरी ऑफ दिस device you will find the IO blocks. Okay, so these can be used for the external connections, so these can be used as the input and output pins, and at the same time we can connect this to the logic blocks and the interconnects. So this is the overall structure of FPGA, which is similar as we discussed earlier. So on the periphery, there are IO blocks. This is the interconnect switches which are present. Okay. And then logic block that is present. Okay. So this is the overall structure of a FPGA. Now, when we are going for the lookup tables, okay, actually logic blocks in a FPGA, we have a lookup tables which are used to implement this logic block. Now, what is this lookup tables? They are formed using multiplexers. Okay, so smaller number of inputs are there for each of this lookup table, and only one output is there. So this contains storage cells that can be loaded with desired value. So now you hear it is a 2 input and 1 output lookup table, which is implemented using 3 multiplexers. Okay, so input is applied at these 2 multiplexers. Okay, it may be either 0 and 1, and so that logic level is applied. Actually, not a, this is not a input, but that logic level, it may be either 0 or 1, and then inputs are applied at used as a select inputs for these multiplexers. Okay, so depending on the logic level which is present at this loop, select inputs, that is x1 and x2. So either 0 or 1 that will be selected. Okay, and then here this is about the output. Then output of these multiplexers that will be given to the third multiplexer, and again which input is will be present at the output of this multiplexer, that will be decided by this x1 select input. So we have discussed this part in the earlier session, that this is a XNOR implementation using lookup table. Okay, so here this inputs that are given, that is a 1001, these are applied at the input of these multiplexers depending on whatever is our function. Okay, and then with this x1 and x2, each of the output that we will be present at the output. Okay, so remember that this lookup tables that is using a multiplexer. Okay, then configuration logic block, that is a CLB, that is a present in a FPGA. That number of ways defining CLB, that it varies from simple AND gate to very complex structure which consists of MUX or LUT, and so that is a lookup table. so many PLA kind of structure. Okay, so that will be present in a logic block. So this FPGA logic block actually for Altera Flex 10K that is like this. So it has four input lookup table. Okay, so there are four inputs and output of this lookup table that is given to the flip flop. Okay, at or it is directly connected to the multiplexer. Okay, so depending on the select input, uh, each of any one of this input that will be uh, selected at the output. Okay, so if you are going for the combinational logic circuit, so it will bypass this flip flop and this output of lookup table will be directly connected to this multiplexer. Yeah, but if you are going for the sequential design, then this flip flop that will be there in a fixture, and then output will be connected of this lookup table will be connected to this multiplexer through this flip flop. Okay, so now here this will require certain clock signals, then set and reset signals that will be required. So this is the logic block which is present in a FPGA. Now, as Altera Flex 10K that uses SRAM type, that is a SRAM type FPGA. So that means for the connection, this SRAM is used. So this is the architecture for the interconnection uh, of this inputs or IO pins. So for that here, there is a, you can see, this is the SRAM based connection. So you can program in such a way that it will be connected, or it could, if you want to remove that connection, so that could be done. Now, in a FPGA, we are using in system programming method. That means you can program that FPGA on board itself. Okay, so there is no any need to remove FPGA from for from the board to program it. Then LUTs that contains volatile storage cells. So none of the other PLDs technologies that are volatile. So that is the advantage. So you can program these FPGAs any number of times. Um, so that is the advantage of FPGA. Okay. So now here, if we are going for the custom chips, okay, custom chips. That means the chips which are designed as per the uh, application. Okay, so that are ASICs or system on chip. Okay, so PLDs are limited by number of programmable switches. So because of that, it consumes space and reduce speed. That is one more disadvantage of PLDs. But if you are going for the custom chips that are created from the scratch, that are expensive, but they are used when high speed is required. Okay, because the speed of these chips that is high, and if we want to sell number of same products, that time they are used. Okay, and chips here in a custom chips, that is they are having small size, and also they are having high number of gates. So that is because of that you can implement a very large circuit. So ASICs that are the custom chips, okay, and that uses a standard cell, or it can be totally um, customized uh, circuitry or full custom ASICs that we call it as a, so that, or it can be get a standard cell based ASICs, so that may be present, and that reduces the design cost. If we are using standard cell, then that will reduce the design cost of the circuitry, whatever is cost that is required for the implementation. Okay, so that means whenever we are want any particular application that is customized in the firm, so we can go for ASIC. If we are going for ASIC design, it may be a full custom design. That means प्रत्येक जो काही पार्ट आहे त्या ASIC मधला, so that is a user design and user defined. Okay, or otherwise just you can use a standard cell, you can place it on that chip and route it as per your requirement so that you can minimize the size of your chip. Okay, so that is a standard cell based, that is a ASIC, that is we call it as a CBIC, or it can be again gate array based ASIC. Okay, so this is the difference between CPLD and FPGA. So as we have seen earlier, in a FPGA, gate density is more as compared to CPLD. Then in CPLD we have programmable logic device, but in a FPGA we have configurable logic blocks. So configurable logic block, that means it is using a lookup table, and in a programmable logic device, that means it may be a PLS like structure or PAL like structure. So again CPLD we have and or arrays, while in a FPGA we have lookup table. So these are the certain differences in CPLD and FPGA. Okay. So the configuration context is non-volatile in a CPLD, while in a FPGA this is volatile. That is a one great advantage of FPGA. Okay. So now if we are considering, okay, whenever we are designing any circuitry, that time we need to check for what is the cost of development. Okay, so as a design engineer, this is the most important aspect, that what is the cost of the final product. Okay, and at the same time we need to check for what is the time required to develop that circuitry. So देर आर सर्टन ट्रेड ऑफ. ओके, म्हणजे प्रत्येक गोष्ट जर बघितली की आता आपण जर जेव्हा कॉस्ट मध्ये बघायला गेलो, मला कॉस्ट जर मिनिमाइज करायची असेल तर ऑब्विसली त्याच्यामध्ये काय होणार आहे, मला तिथं पण कॉम्प्रोमाइज करावं लागेल की स्पीड, डेन्सिटी, कॉम्प्लेक्सिटी ह्या गोष्टींमध्ये मला कॉम्प्रोमाइज करायला लागेल. पण जर मला या गोष्टींमध्ये कॉम्प्रोमाइज करायचं नसेल, म्हणजे माझा जर स्पीड मला चांगलाच हवाय, ओके, आय वॉन्ट अ ग्रेटर स्पीड, देन I want to accommodate very large circuitry in a single chip, as well as I want to go for the market volume also, then I need to compromise in the cost. Okay, so I need to go for the higher cost. So that is the disadvantage that we have. So if we look for the logic design technology trade-offs, so you can see here from this tab that if we are using PLDs, that time PLDs will have low cost, but also it will require time for the development, that will be also lesser, but the speed of that device, that is less, as well as complexity that you can have in the circuitry, that is also less. Yeah. Then if you are moving towards CPLDs or FPGA, then it is likely to increase the cost of the device as well as time to develop, but at the same time you are getting good speed there. Okay, and the complexity of the circuit that you can increase. Again, if you are moving towards ASIC, so that again improving your speed, but you have to suffer for the cost as well as time to develop. And then for the full custom VLSI design, that will have a very good speed, it will accommodate a very complex circuitry, very large density of gates that will be present in that circuit, but at the same time we need to suffer, or you need to have a trade-off for the engineering cost as well as time to develop. Okay, so that means cost will be higher, as well as time to develop that circuitry, that will be also higher. So that is the trade-off which we see in a digital logic technology. Okay. So if we look for the applications of this CPLD and FPGA, so we can use this CPLDs where we want certain glue logics that to be implemented. So for that we can use CPLDs. That where we use actually multiple SPLDs, the circuits that can exploit wide and OR gates, and that do not need any large number of flip flops. In that case, also we can use CPLDs. Okay, so in case of FPGAs, this whenever we are having applications such as prototyping, then computers, on-site hardware reconfiguration, DSP applications, or logic emulations, or for network components, we are using FPGAs. So, wherever there is a complex circuitry which requires more number of flip flops, that means where there is a more sequential circuits are present. In that case, we can go for the FPGA. So as the complexity increases, we can move towards the further improved technology, and that is why we can go for FPGAs. So that is about overall this fourth unit, that is sorry, sixth unit, that is the architecture of the commercial devices. Okay, now here remember that are we have seen Max 7000 series, Altera Max 7000, then Xilinx XT9500. These two CPLDs that we have seen. Then Altera Flex 10K, that is the FPGA. Okay, so these are the commercial devices that we have seen, and then in that we have discussed about basics, or we have introduced about ASICs and SOCs. Okay, so that is overall about this sixth unit. So if anyone has any doubt about this unit, they may ask. Any doubt?
No, ma'am.
Okay. Um, uh, are you referring study material that is shared with you?
Yes, ma'am.
Okay. So please check whether I have shared XC9500 PPTs with you or not, and please let me know if I have shared it or not. Okay. Now, one more thing.
आता लगेच सांगू दे मॅम.
नंतर सांगितलं तरी चालेल. नो प्रॉब्लेम. ओके. फक्त माझ्या लक्षात येत नाहीये तेवढं मी शेअर केलंय की नाही. I think almost all other PPTs that I have shared, but I have not checked whether I have shared it or not. That XC9500. So please let me know. Okay. 23rd was last date for submitting assignment of fifth unit.